Good morning, mathematicians. A little late today. That's all right. I yeah, I decided to come to the office because my roommate was using the living room. I figured it'd be less noisy here, so I'm like, oh yeah, I'll just go to the office and stream. And then I just sat down and reflexively started working on things I'm supposed to be doing. So if my supervisor is tuning in, um, know that I worked. I don't think he's tuning in. But yesterday there was a talk. Yesterday there was a talk hosted by my research group, the Canadian. Was it what's our current seminar called? It's on researchseminars.org if you know it. It's like the Canadian Rockies research seminar or something. And anyways, there was talk about my YouTube channel on there because actually our guest speaker, Professor Lucas Mason Brown, actually, I guess watched one of my live streams or something and just sent me a message to be like, hey, cool concept. Like, I like what you're doing. And then so naturally I looked him up. I was like, oh, who is this guy? And then I was like, oh, damn, I saw his research. And I was like, wow, this is like all stuff that my group cares about. We should invite him to the seminar. And so we did. Good morning, Matthias. Time for you to help you out? Well, good. You feel like it'd be better for you to be able to send a picture rather than typing the problem out in YouTube chat. Yeah. Yeah, it probably would. I guess you could maybe email. I don't know if I want to just pull up my emails on stream, though. Yeah, we should. I need to think about what a better way to interact with everyone is on stream. By the way, I realized yesterday I was saying very stupid things like "Good morning, Super Baron." About the classification of modules. I mean, so I didn't do my homework. I didn't go look at the classification of modules over a Ph.D. to do the general thing. Um, to do the general thing. But I don't think we actually need that at all. I think this problem's much easier. Right. I mean, one thing to note is, so if we let phi be in here, then it's entirely determined because this is a KX module homomorphism. It should be entirely determined by where it sends one, right? So what I mean, that is also a good one. They send it's a little harder to parse than some of the others, but keep them coming. Keep rocking them. Right, because if I have some, like, an arbitrary element of this, is there's going to be some polynomial plus, maybe I should write it like this ideal or submodule, however you want to think about it. But because this is a module homomorphism, this is just going to be, this polynomial acting on phi of 1 plus x to the n, right? Hey, just wanted to make a quick share a quick observation. If you identify fractional ideals as lattices in Minkowski space, then you can compare inverse ideals versus dual lattices. Sure, that makes sense. And the difference is exactly the different ideal. So it kind of plays the same role as a canonical sheaf in serduality, which makes sense what we saw in Neukirch. That makes sense to me in a vague way, but I feel like I don't have a deep understanding. But the overall view of what you just said makes sense. It's just really hard to type out a novel to describe the problem you're having. Yeah, that is fair. That is fair. What's the best solution, gang? What's the best solution? I guess if I just got better, so one, if I actually spent some time to figure out, how the hell OBS works, I could probably have it display certain screens and not others. Yeah, it's just easier to have it display the entire screen. But it would probably be easier then for me to set that up, and then for me to check emails without exposing all my emails on stream. Yeah. Also having a Discord server. But then I'm like, that makes me, then I'm like, I have to monitor 2 chats at once. I mean, if I do go to my office, then I've got a second laptop here. But then that means I'm beholden to my office for live streams, which means no daily song. There'll be no song today. So I don't have any instruments in my office. I really need one. Yeah. Am I familiar with Julia? Yes. Well, no. I know of its existence. I don't think I've ever typed a single line of code in Julia. I went to a conference on formalizing cohomology theories 2 summers ago, and there was a woman there who presented on some stuff about formalizing some kind of cohomology theory, in a proof assistant, but somehow it was also tied to Julia to take care of symbolic computation. Yeah, I don't remember. Yeah, you can add me on Discord and just send me a translated screenshot, I guess, and then I'll open that up. I'll open up my Discord. That's my Discord handle. I mean, if a ton of people send me random friend invites, I'm probably not going to accept 1,000,001 random friend invites. But that is my Discord handle. Yeah, what was I going to say? So, anyways, I mean, this is these homomorphisms will be entirely determined by where they send one. And so, where they send, that's very likely because I have 7K viewers right now. 7K? What? Where are you getting that from? There's no way I have 7K viewers. I don't even have 7K subscribers. I don't even have 7K subscribers. There's probably 10 people watching right now? Yeah, I have 9 watching, it says. I have 9 watching. Yeah. And my typical live videos get 200-300. Well, this one had 348. That was yesterday's, but that's higher than usual, right? Maybe ballpark 250 to 300, something like that. I'm not so worried. No, it's just you logged on from. Well, that'd be great. I mean, go ahead and do that. Log in from nearly 7,000 devices, and Yeah. When did I know I wanted to pursue maths at university? That is a good question. That is a good question. Uh, that's a good question. When did I know? I don't know. I knew I somehow I liked math long before I knew that I liked math. If that makes sense, somehow I was like I didn't realize that I was a math person, even though I was like writing calculus on my bedroom walls, quite literally in permanent marker. My mom thought I was insane. She thought I'd lost my mind. I was also this was also the time that I was skipping class all the time and failing pre-cal, but also simultaneously teaching myself calculus and writing really long integrals on my bedroom walls in permanent marker. And somehow I didn't think of myself as a math person, or did I think like, oh, I'm going to go to university to study math. And then when I first went to university, I was just like, I didn't really care about going. I was like, yeah, I guess I'll study physics because physics is cool. Because that's what originally got me interested in mathematics. Yeah. And then I guess maybe, and I went for a little bit. And then, for a number of years, I took a course here and there. But like, I wasn't really focused on school. I just knew I liked math, so I was taking math courses. I think in the second year, I took like calculus 2, like, sequences and series and stuff and like higher dimensional integrals and things like this. And I think it was in that class, I remember I had a particular professor, shout out Ross Stocky at the University of Winnipeg. And I just remember he was very animated and very excited when he was talking about mathematics. And I just remember being like, I want to do that. I want to talk excitedly about mathematics in front of a room full of people. But even then, I don't think I was like, oh, yeah, somehow it still like took a little while for it to sink in that like a mathematician is like a thing you could be, and like, oh, I'm going to go to school and like try hard and focus on doing this. Did I know that D-brains charges in physics live in K-theory spacetime? Oh, live in K-theory spacetime? D-brain charges in physics live in K-theory. I have no idea what you're saying, man. I have no idea what you're saying. This is a great content question. Make a video, don't spoil it. Wait, what? What? How I got it? When did I know I wanted to pursue math? Yeah, I guess. Oh, we've got. Let me go to my Discord. Let's go. Boom. Well, I'm a mess. Why isn't this working? Is my hands are greasy? Why is Discord frozen? Usernames have been truncated. Okay, sweet. That's good. Oh, that's still, we're waiting on that. Okay. Christian was really in doubt whether you should major in math or physics. In the end, you went with physics. Yeah, fair. It's a toss up. They're both interesting. I get the ideal solution would have been double major. I think, we should have both just double majored. Guilty for starting with physics. That's what motivated you to learn calculus in the first place. Yeah, same here. So I was failing this calculus class, but I was like reading about physics and like pop physics in my free time, brief history of time and books like this. And then I remember I went to like I wonder if it's still I think I was on like the Wikipedia page for general relativity or something, and I found like the Schwarzschild the equation for like the Schwarzschild metric, and I was very confused because it defined what all the symbols meant. Um, it defined what all of the symbols meant, except for the little d's, which of course now I know it's a calculus differential, but I was like, why isn't the d defined? And so I was just trying to solve this equation algebraically and trying to work out the solutions. I was getting like weird numbers, and I thought maybe it was a distance. And so I went to the teacher who was teaching the pre-calculus course, and I was failing. I was like, can you explain this to me? I don't get what's going wrong. And he's like, no, I can't explain it to you till you know calculus. And I was like, well, what do you mean? Why can't you just tell me? And I got really ticked off at this guy because I'm like, well, why the hell won't you just tell me? Like, I was mad. I'm like, fine, screw you. I'll go teach myself calculus. And then my so I decided to go teach myself calculus, and my high school pot dealer, who was in med school — don't do drugs, kids, they're bad, it'll kill you, make your brain dumb — was taking calculus at the time, and somehow we got to talking about this scenario, and he was like, yeah, I'll teach you calculus. And so we went to the public library and he taught me the basics about limits, and that was enough for me to just go from there and, teach myself about integrals and stuff. Would I have wished to have met a prof in high school? Yeah, absolutely. That probably would have changed my life forever. I'd be a, Fields medalist with 400 books on infinity categories in Langlands by now. No, but really, that would have been better. These days, you would have probably chosen math or stats. Yeah, fair. I would probably have chosen stats these days. Because I want money. I want to have a comfortable life and be financially sound. Can I try a step paper? I don't know what a step paper is. Life's good. If you can let me know what a step paper is and where I would find it, such a thing. Sure, why not? Yo, tenacity. Did my prof come out in front of the class and said he has proof of Riemann theorem? Which prof? None of my profs have ever done that. If they would, I probably would have walked out because odds are he would have been a crackpot. How to determine the Langlands dual of some reductive group? That is a great question. Matthias sent their question. I see. Hello. This is what the book did to prove the harmonic series is divergent. Really confused by the 1/2 bigger than, well, maybe I'm guessing this should be bigger than or equal to. Can you help me figure out what they're thinking? Okay, let's take a look. So we have a sequence defined as such, and is claimed. Oh, this is a different sequence. This is a different sequence than the one you were talking about yesterday. It is claimed that this is divergent. Yeah. This is not the proof I would use the proof that a convergent sequence has to the terms have to go to 0. But okay, maybe they're just showing how to do things from definition. Okay, so proof by contradiction. Assume that AK converges to 0. Yeah, let me make chat available here. It's the undergrad entrance exam for Cambridge Maths. Okay. Oh, you want me to try the undergrad entrance exam live on stream? God, that's so risky to my ego. Sure, why not? Maybe let me write that down. Let me write that down. That could make great content. I see it now. Ph.D. embarrasses himself on live stream. Step Cambridge exam. I guess, do they have like a mock exam or something I can try online? Should be 1 over k, you're bad. Well then, this whole thing that's been written here, then, like, I'm not sure you're referencing this, but this picture does not have to do with 1 over k. So, yeah, I don't know. Can you show me the picture with the 1 over k? Because now we're talking about two different proofs here. Didn't another roof kind of fumble on Tom Rock's math when confronted with something similar? I don't know. I know of Tom Rock's math. I don't know another roof. Maybe, yeah. But I'm down. I'm down to embarrass myself. I mean, I do this on live stream every day. I will look at this simple like module problem, and I was saying like stupid things yesterday. I haven't even finished doing it yet today. Okay, well, yeah, Matthias, if maybe carefully look at this proof again, and then and let me know. You're still confused by the argument at the end. Well, remember, so here's the idea. Let me just tell you the idea. Another roof is pretty cool channel. Maybe I'll check it out. Right, the idea is this. What do we need to do to show that this what does it mean to show that the series converges? Well, that means that we have some A such that for all epsilon there exists an n where n bigger than or equal to n implies that a sub n minus a is less than epsilon, right? And so if, right, it would be a contradiction then if we could find, if say we took 1/2 for our epsilon and we then found some number, let's say n plus 1, right? N plus 1 is certainly bigger than n. And we found the case where some n plus 1 bigger than n, we had a n plus 1 minus a, if this was bigger than 1/2, right? That would contradict this part of it. So that's the main idea of how this proof is working, right? Russians call hard math entrance exam questions caskets, like stepping into an open casket. Love it. I'm here for the brutality and the severity. By the way, not that I'm at all equipped to actually do this. I've said this before. We need to bring back the math battles of like 1700s or like 1500s Italy, where people would just like publicly challenge each other to math questions. We got to bring that back. Langlands dual group. I can talk about that, though. Someone asked about the Langlands dual group. I can talk about that. 100% I can talk about that. Basically what it is. I do have plans on making videos about like Lie theory and root systems. Well, let's see. Hang on. Matthias has a question here. The thing is, as it is written in the book, you just confuse yourself saying that it was a harmonic series, because it's not. Yeah, not the harmonic series. I have not tried the non-standard approach to analysis, and I don't know if I ever will, to be honest. He might be right. There might be some upsides, but There's only so many hours in the day. I did get a haircut. You can duel me for my PhD candidacy position? Let's go. Let's bring it on. I mean, it's kind of unfair because on stream, you've sort of carved out a bit of a base of the things I know and the things I don't. Can I plug an app you made for researchers to be able to use on Archive? Yeah, I guess why not? You just drop it in chat. But let's talk about Langlands Dual Group. So I am going to make a series on. I am planning, based on the poll, seems like people want more about Lie algebras and the classification of Lie algebras and root systems and stuff. But let me just say that so coming out of that, we have a group, say some algebraic group, let's say, GLNK or SONK, blah, 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 all of these matrix groups, SP, SP2NK, all of these matrix groups. And the general idea is that we have some sort of, attached to this is a root system. So, if we have, say, for instance, there's Lie algebras associated to all of these things. Well, okay, there's different ways to talk about the root systems. We could do it. You can do it in a purely Lie algebra sense, but instead of talking about this Cartan algebra, good morning, Nicole. Good morning, Nicole. You got in late. I also got in late. Started the stream very late. So instead, you can talk about the torus acting on this Lie algebra. Can I say the definition of an algebraic group? I should be able to by heart, but wow. Let's just say a group object in the category of K-schemes. Yeah, it's more complicated than that. Algebraic groups are more complicated than that. There's a copy of Springer floating around this office here. Yeah. Algebraic means something more. Algebraic means something more. No. Well, I could look it up. Let's see what the formal definition is. How about without schemes? Yeah, you don't have to do it with schemes. You can do it just in terms of varieties. An algebraic group over field K. Oh, I'm confusing it with linear group. So it should. Never mind. It is literally just a group object in the category. Yeah, literally is just a group object. You could say of K varieties. Yeah, you don't have to talk about schemes. But then the real GigaChad approach would be, go look at the beginning of Getz and Han. Affine group schemes. That's what we want. Yeah. And they do the functor of points perspective. So go buy their book and read about it there. Anywho. So we take our Lie algebra and we break it up into eigenspaces. So there's the zero eigenspace, and then we get a direct sum over some eigenvalues. So that is G sub alpha is everything in G, such that conjugation or the adjoint map by T acts by this, for all T in T, where alpha is some character of the torus. And I guess our base field K. right? The real GigaChad would be EGA. Yeah, maybe. I don't know. Yeah, that's true. It would be. What do I think of Schreiber work connecting the categorical formalization of Hegelian dialectic with string theory? Some esoterical material. I don't know. That sounds like nonsense. I haven't looked at it, so I can't give an honest opinion, but I don't know. I don't know. No part of that seems interesting to me. I mean, I am kind of interested in how category theorists have formalized the Hegelian dialectic in category theory. That seems interesting. Not enough that I've felt the need to sit down and actually learn it, but then yeah, I don't know. Connecting it to string theory, like why? Yeah, I don't know. The ad, yeah, not the YouTube ad. It is very much related to the map in differential geometry. I mean, uppercase ad basically just means conjugation. And lowercase ad, say of a Lie algebra, just means take the Lie bracket of these two elements. Yeah, well, maybe Deepak, maybe just say like what the name of your app or whatever is, or something, and people can look it up. There's a YouTube channel connecting topology to Lacanian theory. A little too out there for me. I don't even know. What is the channel? Can you say what the channel is? I don't even know what Lacanian theory is. But okay, so coming back to this, so we can decompose our Lie algebra in terms of eigenspaces with respect to some sort of like characters of the torus. So this, phi is like a special subset of the characters, right? And this gives us a root system, and you just did using the dots? Huh? So we have this, and then there's also a choice. There's like a choice of roots that we call positive roots. So, for example, like we saw in a previous stream how like SL2C broke up as this like direct sum, and so we could call these the positive roots. Actually, there's something stronger. We want to take what's called a base. We want to take simple roots. So there's something even stronger than that. So this is maybe a bad example. So you can maybe believe in the same way SL3 breaks up. There's sort of a smaller generating set, let's say, that gives us our simple roots. Likewise, there's also so alpha. And we've actually talked about this before on stream. So alpha is a character. What am I talking about? Alpha is a character from the torus, right? And there's also a notion of a co-character, right? Which, if you view, your torus is just isomorphic, to like n copies of k. So like a co-character is then going to it'll take some element x in k, and it'll just put that element to a bunch of like integer powers. Forgot the name. Well, okay, I probably wasn't going to look at it anyways, to be honest, or do a deep dive. I am kind of interested though, actually. You can send it to in DS archivavite on Verso. Paul Maurice, you're asking me. I haven't even finished your question about the Langlands dual group, and you're already asking me about equivariant cohomology, P to the N. Archivite on Verso. This first one? Let me know. I'll come back to it in a second. So there's there's likewise, so we have this root system and some sort of we also have our some sort of special choice of like generating roots, and then there's like a dual. Don't tell me you're sorry for the spam. You're not sorry. You want to shamelessly plug your stuff, as do I. So don't tell me you're sorry if you don't mean it. Vercel app. So how does this work? What do I do? Search papers. Langlands. Yeah, no, you're gonna have to. Oh, Matthew Sunahara. I know him. I should maybe look at that. Stable harmonic analysis and stable transfer. Ooh, that seems interesting. And it's fresh. Just dropped. I'll be honest, though. I don't see why I wouldn't just go to Archive, which also compiles all of this stuff. Yeah, sorry. Let me get back to the Langlands dual. So here's a point. So that's basically how we get our root system, right? It comes from this data of like decomposing. This comes from our data of like decomposing the Lie algebra, like this, based on the characters, right? And then there's a theorem. So for all of these, for every algebraic group, we get like a root datum. I don't know. You might call this phi. But now the claim is that over an algebraic. So now instead, if you're given a root datum, so there's like a general definition of what it means to be a root system. You can go. Just Google like, oh, what is a root system? There's a general definition, right? And it's basically just built out of the properties that these things tend to satisfy. Well, it turns out over an algebraically closed field, there's a unique group up to isomorphism. It exists a unique group up to isomorphism such that the root system of this group corresponds has that root system or like an isomorphic root system, right? So what am I gonna say? So yeah, maybe I'll. There's a toolbar at the bottom. I do see the toolbar. Yeah, I don't know. You'll have to. I'll need a primer on how to use this. Given right. And so what does that mean? Well, that means, in particular, the Langlands dual goes like this. Basically, you take your group, you get the root system, right? So this will be, x star, delta, x lower star, delta check. And then what you do is you take the dual root system. So what that is you replace x upper star with x lower star and delta with delta check. Right? And now this is a new potentially different root system. And so over that algebraically closed field, you should be able to get some other group. Let's call it H. Well, actually, here's what I'm going to call it. I'm going to call it G hat. Or maybe sometimes people call it G check. Whatever. I'm used to calling it G hat, but whatever. Let's call it G check. G check, and this is the Langlands dual group. So what does that look like? Well, it turns out that for GLN, it is its own root system. So I'll write. I mean, for me, I work over the p-adic numbers. Definitely not algebraically closed field. But okay, for certain reasons, I'm not going to get into. We look at like associate these to like complex reductive groups. So its dual group, we take its root system, right? Take the root system of GLNQP. Now take the dual root system and then plug that in over the complex numbers. We should get some complex group. Well, it turns out it's just GLNC because that root system is self-dual. SLN, on the other hand, if we go SLNQP, then we will get PGLNC and vice versa. And then specifically, Paul asked about the symplectic group case. And so SP2N will go to SO2N plus 1, C, and as you might expect, the exact dual statement is realized as well. Right? So... yeah. Yeah, some groups don't really even have a known construction without this approach. Well, is that true? I mean... is there a book that compiles every time one uses the word dual in its many contexts? I had the knowledge. If I had the knowledge, I would do it. I don't know if that's a worthwhile book. It just comes up too much. There's just so many, and there's so many different kinds of dual. There's just so many different kinds of dual that, I don't know. What is the double dual, the identity? Yeah. So on the level of root systems, if you take a root system, the double dual as a root system will be isomorphic. Yeah. How to see this explicitly, say, for SL2? Okay, well, first we need to recognize the root system for SL2. We need to recognize our roots. So let's go to SL2, which is SP2, by the way. So we go to SL2. Let's figure out our root system. I mean, we have our torus, right? Our torus is just the diagonal matrices in here, right? So our characters of the torus is just going to be the Z module, where every character is just given by sending T inverse to T to the N, is it? I think. And likewise, our co-characters are also isomorphic as to Z as Z modules, where we send T to T to the M, T to the minus M. Right? Great. And what else do we need to describe this root system? Well, we want to decompose SL2 into our eigenspaces. So we want to conjugate. Well, remember we had this basis, right? We had this basis given by what was it? These matrices in our Lie algebra. And I picked this basis for a reason, because this already gives us our answer. So this thing is the Lie algebra of the torus. So we ignore that part. That's like the Cartan subalgebra. This is just the Lie algebra of the torus. So what we're really focusing on in these sums are these things here. And so, well, sure enough, I mean, this aligns. We did the computations differently. We did it in terms of the Lie bracket, which is the lowercase add. But then the story is actually equivalent with the uppercase add. You know, you simply like look at this. You know, take the add of this. So I'm conjugating. This, and what do you find when you do the calculation? This will be t squared. And likewise, you know, add of this acting on the other matrix will be t minus t to the minus 2. So our root system, well, our roots are given by two roots we call alpha and minus alpha, where alpha is the character that takes this and returns t squared, right? You can also use what you like to call AD, both capitals, where you let G act by conjugation on its own one-parameter subgroups. Isn't that... I don't... I'm not sure I understand. Isn't that just ordinary add? Uppercase add? I'm not sure. It is 9:26. I should probably go and continue working and stuff. But we will come back to this. So well, we've worked out the root system. Now we need to work out what the dual root system is. Well, first off, okay, so let me say so like before, here it's easy to I mean, okay, there's a more technical definition of positive roots and negative roots, but like, or simple roots. Here, I mean, definitely you can see which is going to be the positive roots and which are going to be the negative roots. And you can take alpha, that'll just be like, that's going to be our simple roots, right? So that's fine that we have this one simple root. So that gives us our root system. Well, part of it. So we have that. We've got our one simple root. What about our co-roots? Well, we also need, there's a pairing here between our root systems that we need to address as well. And so it's a pairing between the characters and co-characters. It comes from this pairing between the characters and the co-characters, which we've also talked about before on stream. So basically what it does is, so alpha, beta is basically, this will be an integer. And what is the integer? It's the integer that results from applying beta and then alpha. Because, I mean, what is this? Like, in our case, for example, beta is going to be like t to the m, t to the minus m for some m. And alpha is then going to be well, I didn't mean to confuse it with the alpha above. My apologies there. I didn't mean to confuse it with the alpha above. Is it... Wait a second. I feel like I'm writing something silly. Is it just the product in this guy? That can't be right. No, that must be right. Am I saying something silly? I mean, the point is the integer is defined. I mean, if you apply t, you apply beta to t, you get an element of the torus. You apply alpha, you get an element of your base field back. So maybe I should call this x, not to confuse it with an element of the torus. And the point is this will just be x to some integer. And so we define the pairing to just be the integer that happens when you make this application. What is z sub I? Oh, that's a comma. It's a shitty comma. That's what it is. Yeah. But I do. Yeah. I need to go. So I think this is where we'll pick up next time. Even though I'm kind of spoiling the whole series. Well, I don't even know when I'll get around to actually making the Lie theory series and the classification theorem. And when I do it, I'll do it more properly. You know, it'll be a pre-recorded video, and there'll be better proofs and stuff. But I'm gonna call it. It's time for me to go prove things. It's time for you to go prove things.